Welcome back, students. Pushti sir again here today to give you some good input into the spring mass system. Is simple harmonic motion involving spring mass system. These are my credentials, as you all know by now. Today we discuss a very typical question. Just see the question. This is a rigid roof, two springs, ideal springs hanging, and a pulley, ideal pulley means massless and frictionless pulley P1 is supported by them, and from the center of the pulley P1 another ideal spring K3 whose spring constant is K3 is hanging, supporting one more pulley P2 which is also ideal, massless and frictionless. Okay, and two masses M1 M2, two blocks M1 M2 are hanging from the pulley P2 with the help of a string which is also ideal string. Ideal string means inextensible and massless. So now the question is, if it is slightly disturbed, all as I give the values, K1 is K, K2 is 2K, K3 is 4K, M1 is M, M2 is 2M. We'll use them later. Okay, let us see. What is the question is? M1, M2 are point masses. Find the time period of oscillation of spring P2. Okay. Since the P1, P2 are massless, then oscillation time period of P1, P2 both will be same. That proof is a different question altogether. Okay. But I am asking for the oscillation of this P2, oscillation time period of this P2 where the masses are hanging. So what is the solution of this question? See this diagram. If it is a single spring and a single mass hanging from a roof, you can, all of you I think can answer the question. 2 pi root over m by k is the time period. But it is not so. It is a combination of springs and a combination of masses. So solution is step 1. Find the equivalent spring, single spring of the combination of the springs. Step 2, find the equivalent mass of the two blocks hanging from the pulley P2. That equivalent mass will be one single mass. Then my problem will be solved. So step 1, finding the equivalent spring of the combination. How to do this? How to find this equivalent spring? All of you must have done till by now, or even not done, don't worry, I'll give a general method for that. Just remove that P2 because below P2 there is no spring. So spring is connected up to P2 only. Just show the springs K1, K2, K3 and write a single spring equivalent of this. Just see, this is equivalent. Apply force on K3, that is F. Same force you apply on the single equivalent spring, that is same F. If the energy stored in these three springs due to this force F and the energy stored in this single equivalent spring due to this force F, if they are equal, then I say this KEQ, the single spring, is the equivalent of the combination of three springs. So that's what I wrote here. Apply force F to the combination as well as to the single equivalent spring. Energy stored in both must be same. Energy stored in the given system of springs, how much? Let us come to the diagram again. This is F. This is massless spring, ideal spring. So this must be F. So this is F. Since this pulley is massless, this is F by 2, F by 2. So this spring force is F by 2, F by 2, F by 2, F by 2. And here also F by 2, F by 2. Okay. So both the K1, K2 springs, their force of extension is by 2 in each, and the force of extension is K3. This spring, whose spring constant is K3, that is force of extension F here. So the total energy stored, as you know, F square by 2K is the energy stored in any spring, any ideal spring. So F square by 2K3, F by 2 whole square by 2K1, because here the force is F by 2 in this spring and in this spring. So that's what exactly I'm writing. F by 2 whole square by 2K1 plus F by 2 whole square by 2K2. F square by 2 take common, 1 by K3 plus 1 by 4K1, 1 by 4K2. Just you add, you get this values. F square by 2, 4K1 K2 plus K2 K3 plus K1 K3 by 4 K1 K2 K3. Now come to the equivalent single spring. Same force you are applying. His spring constant is K equivalent. So how much energy stored? F square by 2K equivalent. Same. Energy stored in the equivalent spring is F square by 2K equivalent. Now equate these two. So if I equate, I write this. So K equal H square by 2 cancel from both sides. So K equivalent will be 4 K1 K2 K3 by 4 K1 K2 plus K2 K3 plus K1 K3. And put their values. K1 is K, K2 is 2K, K3 is 4K. Similarly, here put those values. K1 is K, K2 is 2K, this is 2K, this is 4K, this is K, this is 4K. How much it is? 8K cube, not 8, 32K cube divided by 8, 8, 16, 20K square. So 8 by 5K. This is the K equivalent. Okay, job is over. Now, next step is find the M equivalent. Let's go to the second page. Okay, we go to the second page. This is the second page. I come here to calculate the M equivalent. Just see this from the pulley P2. Two blocks are hanging M1, M2. How much? Suppose this two blocks are hanging from an ideal pulley which is supported by a string from the roof. What is the tension here in the string which is connecting the pulley to the roof? And we put a single mass if with the help of an inextensible string, massless inextensible string. If it produces the same tension here in the string, then this M equivalent, and this M equivalent is the single mass is the equivalent of M1, M2. Understood this? This is just a hardwood mason. You know, this pulley is a massless, frictionless pulley, ideal string. This is also ideal string. This is hanging from the pulley is hanging from a roof with the help of an ideal string whose tension is T, because they will accelerate M1, M2 greater than M1, they will accelerate, and some tension will be there in these two strings and double the tension will be there in this string. And now this is a single mass hanging from the roof. This is roof, this is the roof, they both rigid roof hanging from the roof. So this tension in the string supporting this single mass is T, and this tension in the string supporting the pulley also T. If both have the same tension, then we say this mass M1, M2 has a equivalent mass M equivalent. So our M equivalent is the equivalent of M1 and M2. Because whatever the acceleration, whatever tension is getting, if the same tension we are getting by a single mass, then the roof will think that this, as far roof is concerned, this single mass and this M1, M2, there is no difference for the roof. That is difference for the string hanging from the roof. So this is the concept of equivalent mass. So mass M equivalent must produce the same tension in the string hanging from the roof as produced by the two masses M1 and M2 in the string hanging from the roof. As you know, all of you know, must be very basic from the Newton's law, Arthur's machine. This is the Arthur's machine. What is this tension? It's the same tension because pulley is massless, frictionless. So the tension here and here, as you know, must be. We know the tension in the string connecting the two blocks is 2m1 m2g by m1 plus m2. This tension is, we call it T1, 2m1 m2g by m1 plus m2. Then what is this T? 2T1, that is 4m1 m2 g by m1 plus m2. Okay, that's what I wrote. So since the pulley is massless, the tension in the string hanging from the roof will be 4m1 m2 g by m1 plus m2. Now in the equivalent system, there is a single block hanging from the roof with the help of an ideal string. So this tension will be equal to M equivalent into G. Yes or no? That's what I wrote. In the equivalent system, tension the string hanging from the roof is M equivalent into G. Equating these two tensions, 4m1 m2g by m1 plus m2 is equal to M equivalent G. What is M equivalent? 4m1 m2 by m1 plus m2. By G cancels. So now put the values. 4, m1 is m, m2 is 2m, m plus 2m. So it is 8 by 3m. So in first page we knew the k equal 8k by 5. And now this second page we have calculated M equivalent 8m by 3. So now the new system, equivalent system, therefore the given system can be reduced to a single equivalent spring mass system hanging from the roof as shown in this diagram. The single spring constant is 8k by 5. That single equivalent block mass is 8m by 3. So angular frequency is k by m root over. So k equivalent by m equivalent root over 8k by 5 by 8m by 3. So 3k by 5m. Root over of 3k by 5m. What is the time period of oscillation? T is equal to 2 pi by omega. So 2 pi into 5m by 3k root over. Very simple. Otherwise, these things would have been a bit complicated had you gone it from the first principle itself. So reducing to a single spring and a single equivalent spring and single equivalent block, it became very much simple to solve this type of questions. Am I clear? I think people must have understood this. Go through the video. Wherever you find difficult, you contact me, giving my number, and again we'll meet with a new question, new interesting question, but conceptual. This you see, you can, if any sort of questions asked like this, you can now answer without fail and without difficulty. Okay? And I told you one very important point, P1, P2 will have the same time period of oscillation if both of them are massless. So that proof we'll do later. Understood this? But if one of these mass pulley is having mass, then things will be different. This will be a 2 degree of freedom case. So right now, this single degree of freedom, we don't worry. Your syllabus is limited to single degree of freedom. Am I clear? Very nice. So we'll stop here today. We'll meet again next with an extremely important but interesting, useful question. Thank you.